All right, let's look for the smallest number that is evenly divisible by every number from 1 to 20. And first we need to talk about what do we mean by evenly divisible. For example, we say 6 divides 42 because there exists this number 7 such that 6 times 7 equals 42. And the same idea for the other two examples there. And so we have 6 times k equals 42, so 6 divides 42. And we're going to take this as our definition of evenly divisible. If and only if a times k for some k equals b. We'll need that. The other thing we're going to need is the idea of every number can be written uniquely as its prime expansion here. So we have the prime powers as the bases, and then some zero or positive exponent for all the prime powers. What does this look like? For example, we have 42 divides 840. Well, instead of talking about 42 as a number, we can talk about it as 2 times 3 times 7, where all those exponents are 1. 840 gets a little more interesting because there's more than one power of 2 in the expansion for 840. So instead of writing 840, we can write 2 to the power of 3 times 3 to the power of 1 times 5 to the power of 1 times 7 to the power of 1. And in fact, we have 5 to the power of the 1 on the right. We can still write 5 on the left. It's just to the power of 0. Why is this handy? Well, I claim that our evenly divisible condition is equivalent to just saying that these powers are less than or equal to. Looking at 42 dividing 840, that's just saying, hey, the powers of 2 found in 42 are less than or equal to the powers of 2 found in 840. And the same thing holds for every prime found in that prime expansion. Now I'm claiming this, we need to prove it. In order to prove an if and only if, we need to prove both directions. So first, let's assume that A divides B. What do we know if A divides B? Well, we know we have this equation, AK equals B. I'll write it backwards this time, though. And now, because B, A, and K are numbers, we can write them as their prime expansions. Here I just wrote 3 primes, so I don't have to write ... all the time. Multiplying on the right-hand side, what do we get? Well, we get some number on the right equals some number on the left, and by the uniqueness of the prime expansion, we actually get that these exponents have to equal each other. So for example, f sub 1 equals e sub 1 plus g sub 1. And in order for this to be true, those e's have to be smaller than those f's. And so that we get the conclusion that we're looking for. Going the other way, if we assume the e sub I are less than the f sub I, well here we can actually solve for k. And this would be a proof by construction here. We're going to find k, which is a positive number, satisfying the equation. Writing our prime factorization for b and a, when we divide, the exponent rules tell us to subtract, and because the f sub I are bigger, the left-hand side is just primes to some zero or positive exponents multiplied by each other, so k is indeed just a normal number. We'll take a pause here, and I want you to try and use this knowledge to find the smallest number that's evenly divisible by all the numbers from 1 to 20. Go ahead and let us know in the comments how you did. All right, let's go ahead and use this fact, and what we're going to do is we're going to look at all the numbers of 1 through 20 and look at their prime factorizations. We know that our number, our final answer, has to contain, essentially, all of these prime powers. And what do I mean by that? Well, we can start with 1 divides 1, so everybody's to the power of 0. But now I need a power of 2, and I need a power of 3. And now I see I actually need 2 powers of 2. And we can just keep going down here, and every time I see in my list a power of a prime that's greater than what I currently have in my number, I need to increase that power of that prime in my number. And so after 20 iterations of this, we actually get the smallest number that that's evenly divisible by 1 through 20. And you'll notice some of these don't actually contribute. There the 2 to the power 4 did, but look at 18. 18 doesn't contribute here because we already have a power of 2 and we already have 2 powers of 3. But at the end of the day, we get our final answer, and that's all there is to it. Thanks for watching. Don't forget to like and subscribe, and I'll see you next time.